Assalamualaikum and good afternoon to everyone here today. We are Group Irfan. Today we are going to present our operating system project focusing on network infrastructure and Linux services. Our team consists of 4 members, each responsible for deploying a critical enterprise services on our Linux environment. Myself, Muhammad Zulhilmi, handling the SFTP server. Then Muhammad Irfan, who managed the DHCP server, Muhammad Syazwi Azim, who deployed the web server, and Shasi Tharan, who configured our database server. Now let's dive into our project overview. As IT system integrators for BITS1213 Company, our main objective was to design and deploy a secure private virtual network. To achieve this, we utilized Oracle VirtualBox as our virtualization platform, setting up a virtual Linux server and a virtual Linux client, both running Debian 11. On our server, we successfully configured 4 core network services. First, a DHCP server to auto-assign IP address to client machines dynamically within the range of 192.168.1.5 to 192.168.1.10. Second, an SFTP server to allow secure encrypted file transfer using SSH. Third, an Apache Power Service server to host our internal company intranet. And finally, a MariaDB database server to handle structured data storage and execute SQL queries efficiently. Now let's look at how these systems are interconnected through our network topology. This diagram illustrates our network architecture. As you can see, our setup relies on 2 main network interfaces configured on our Debian server. The first interface is ENP0S3, configured as NAT. This provides the server with DHCP and direct access to the external internet for updates and package installation. The second interface is ENP0S8, which acts as our internal network named INTnet. It has been assigned a static IP address of 192.168.1.254 with a /24 subnet mask, serving as the gateway for our local network. Connected to this network internal network is our virtual Linux client. The client interface ENP0S3 is linked to the same INTnet internet network. Instead of setting a static IP manually, the client automatically requests and receives an IP address from our pool of 192.168.1.5 through 192.168.1.10, successfully managed by our server DHCP service. This isolates structure ensures that all 4 services, DHCP, SFTP, web, and database, run securely inside our private local environment while keeping the server management. That's all from me. Now I'll pass to the next speaker. Thank you.
Assalamualaikum and hello. My name is Muhammad Shasi Azim bin Bahar and I'm gonna explain about network configuration for our server. As shown in the slide, we set up 2 different network adapters to balance external access with local security. For the first one is adapter 1, NAT. By going to settings, network and enabling adapter 1, we attach it to network address translation. Its primary purpose is to provide external internet access to the server, allowing us to safely download updates and packages. For the second one is adapter 2. Adapter 2 is set up as an internal network. We enable this under the adapter 2 tab and attach it to the internal network layer. This creates an isolated private environment that allows our server to communicate securely with other virtual machines without any outside interference. Together, this dual adapter setup gives us the perfect balance of internet connectivity and isolated local testing. That's all from me, and I will pass to the next presenter.
Hi everyone, my name is Shashi Raou, and my slide is about configuring the server's network with a static IP address. First, we edit the /etc/network/interfaces file using the nano editor. Then we configure the EPN 0S8 network interface with the static IP address 192.168.1.254 and the subnet mask 255.255.255.0. After saving the configuration, we restart the networking service using sudo system l restart systemctl restart networking. Then we verify the configuration by running ipaddr show enp0s8. If the output shows 192.168.1.254/24, it means the static IP has been configured successfully. This step is important because the server needs a fixed IP address so that client computers can always connect to services such as DHCP, SFTP, web server, and MariaDB. So let's look into some examples. So at first, this command displays the network configuration file. Here, we can see that the ENP0S8 interface is configured with the static IP address, which is 192.168.1.254. So for the next, this command verifies the network interface. The output shows that ENP0S8 is active and has the static IP address, which is given here, 192.168.1.254. So for the restart the networking service, so this is a procedure for sudo systemctl restart networking. This command restart the networking service, so any changes made the network configuration will apply after this restart. So for next, so let's test the connectivity from the client Linux. So that so it's successfully connected. This command tests the network connection and successfully reply confirms that the device can communicate with each other. So that's all from me.
Hello everyone and welcome to this section of our presentation. On this slide, we are continuing with our network configuration. Before that, my name is Irfan Bakar. We will specifically look at the final two steps, setting up the client virtual machine and running our connectivity tests. For the client, we configured BITS1213 to be attached to the Ethernet network. We set the Internet network name to INTnet. This is a crucial step because it must match the name we use for the server perfectly to ensure they can communicate. Once the setup was complete, we move on to step 6 to perform our connectivity test. We ran 3 specifically ping tests to verify our network routing. First, we ping IP address. We ping this IP address from the server. Which was successful. Next, we ping from client. Sorry. Ping TC4 192.168.1.254. Alright, this is also was successful. So next we attempt to ping network from client, internet from client, like ping TC4 8.8.8.8. 8. This ping is failed. This is failure confirm that our client machine is probably isolated within the internet network and does not have direct internet access. This completes the network configuration portion of our setup, ensuring our server and client are properly connected yet secure. Alright, moving on to our first core service, we have the DHCP server, and I handle the setup for this section. To briefly explain, DHCP, which stands for Dynamic Host Configuration Protocol, is designed to automatically assign IP address to device on our network and our architecture. I host the DHCP service on our Linux server via the internal interface, which sits at the IP address 192.168.1.254. I specifically configured the server to distribute IP address to our client from a defined pool starting at 192.168.1.5 up to 192.168.1.10. Now, we're setting this up involve 4 straightforward steps. Alright. First, I install ISC DHCP server package using the apt package manager. Just update the server first, sudo apt update, and then sudo apt install ISC DHCP server -y. Next, I edit the default configuration file to ensure the DHCP service only listen to on our internal network adapter. Just type sudo nano etc/default /isc-dhcp-server. Just put enp0s8 at interface v4. To exit, Ctrl X. Alright. In the third step, I modified the DHCP configuration file. Here I define our subnet, set the IP range, and specify the router and DNS server details. Just type sudo nano -etc/dhcp-dhcp-d.conf. Like you can see, this I type for set the IP address and range. After this, you want to exit, Ctrl X. After that, just restart the DHCP server and see the status is active or not. Just type sudo system ctl status isc-dhcp-server. As you can see, it active and running. Alright, to exit, just click Q. Clear. Alright, next, we testing the result from server to test the IP address at client. First, we see the client. What is the IP address? Setting. We can see the address automatically at 192.168.1 and 5. Alright, now we test it from server to client. Just ping C4 192.168.1.5. Success 100% without loss, and we test from client to server. C4 192.168.1.254. And it also 100% packet transmitted without packet loss. Now, all tests Alright. Alright. To validate the configuration, I conduct 4 key tests. First, I check the client and configure it successful to receive the first available IP. So we need to check the IP from the client. Sorry. We see it automatically put 192.168.1.5. After that, we see the testing client IP address. From server, we test the IP to client, ping -C4, 192.168.1.5. As we can see, which was successful. After that, ping server from client, 0% packet loss. We open the client, ping the server. I made sure the client was able to ping the server with 0 packet loss, configuration, internet connectivity. As we can see, 0 packet loss. Alright, next. Ping internet from client. Ping internet, ping NTC 4.8.8.8.8. Third, as intended by our solid network design, pinging the internet from a client failed, resulting in 100% packet loss. Wait and see, and here 100% packet loss. And next, server internet access ping 8.8.8.8. Okay, we open the server and we test to ping the internet. Finally, we obtain the ping 8.8.8.8 from the client. As lastly, I verify the server itself still maintain its internet access by successful pinging Google DNS. All tests passed exactly as expected, confirming our DHCP server is function perfectly. Just that for me to about DHCP server. Thank you.
Assalamualaikum and greetings. My name is Muhammad Zulhilmi bin Sahril. My matrix number is P0325101006. So now I'll continue with SFTP server. What is SFTP? SFTP is a secure file transfer protocol which allows transfer file encrypted over SSH. A dedicated user with chroot tail restriction is created to ensure secure, isolated file access. So the first step is we install the SSH. So the command we need to use is sudo use the admin command to install the OpenSSH. So the command is sudo apt install OpenSSH server -y. Then we need to install the system ct1 and we will enable this word open.ssh. So next step is create SFTP user. SFTP user we will create in the server OS. Now the command is sudo add user SFTP user, then sudo we will create the directory in SFTP user. So mkdir -p/var/sftp/uploads. Then we need to configure the sshd config. So this is the command which is match user SFTP user, then force command internal -sftp chroot directory /var/sftp password authentication we need to enable, so we will yes, then allow top forwarding is no. So after all this step is done, we need to restart and test. So the first one, let me open the server and create the file first. So server Need to open the terminal. Okay, so in server, this is my user right now, ProjectIrfan, which is not SFTP users, but I will create the file in SFTP user. So the command is sudo touch var SFTP uploads. The file name I'll put is s.txt. Password BITS1213. So as you can see now, the file is created. So now let's move into the client. We will hide the server. Go to client. Client. Okay. So now let's move to client. Open the terminal. Okay. So to get the file to be put in the client, so the first step is you need to log in to SFTP user in the server. So the command is FTP SFTP user at 192.168.1.254. So the password 3. Okay, so now it is connected. So now let's check the file first. Yes. So the directory is upload. So let's move into the directory first. cd upload. Now we are in the upload directory. Let me just to be clear. Okay, so now we are in upload directory. So as you can see, the file that I create, which is zulhilmi.txt, is already in the directory. So now let's move this file to the client. So the command is get zulhilmi.txt. Fetching. Okay, now as you can see here, it already complete. So let's switch here. Okay, the file still in directory. Let's exit first. Exit. Okay, now we're in ProjectIrfan client. Now let's check the file, which is it already in the client or no? Oh, yeah, as you can see, zultest.txt is already in client directory. So just need to open the files. There it is. So my tutorial is complete. Thank you.
Hello and Assalamualaikum everyone. My name is Muhammad Syazwi Azim bin Bahar. Today I will be presenting the setup and configuration of our web server using Apache. For this project, we choose the Apache HTTP server, a widely used open source web server. Our main objective was to configure it to the host to the internal intranet page for the operating system. Once configured, this page needs to be accessible across the network at the IP address 192.168.1.254. For the step 1, which is installation. For the step 1, we need to type sudo apt update. For the first one, to update our package, and then we type sudo apt install Apache to install the Apache package. Which is this one. And then the output will be right here. For the step 2, we type sudo systemctl status apache 2, which is right here. This one is the confirmation that the Apache service was indeed active and running. For the next step, which is we need to create the web page. We need to type sudo nano space var html index.html. Make sure that all of this you are doing on the server, not on the client. So this one I already typed to it and then if you already type it, you just ctrl x and then for the server is complete, and then we need to create, no, I mean we need to test it for the client. This one is server and this one is client. For the client, we need to type curl http. This one is the IP address that we already inserted. So this is the completed one for the terminal, and then we need to test it at Firefox. Firefox http 192.168.1.254. So this is the completed web server for Apache. So, and then that's all from me about web server for our mini project. Thank you.
Hi, my name is Shasi Raou like Murugan, and my metric card number is B0325101127, and this is my individual part. So my slide explains the database server using MariaDB. MariaDB is an open source relational database management system used to store and manage structured data. So for the first command, you can see install MariaDB. That shows sudo apt install MariaDB -server and space -y. This command install the MariaDB server on the Debian machine. For the next, we can see here secure installation. For the command is sudo mysql _secure installation. This command secures the database by setting a root password and removing insecure default settings. For the next step, we created DB and user. So this is a command for that: create database BITS1213 DB and so on. This explains. So here we create a database, create a user, and grant the user full access to the database, so he can access all the database. So for step 4, the command is sudo systemctl restart MariaDB. After enabling remote access in the configuration file, we restart the MariaDB service so that changes take effect. So after restart the machine, the updates will included inside the machine. So let's move on for the demonstration part. Okay, first I check that the MariaDB service active and running on the server. So for that, so this shows that the MariaDB is successfully running in our server. So for step 2, We log in into the MariaDB server using the administrator account. That is the server Linux. So for step 3, let's display the databases of MariaDB. So this is the databases. It includes BITC1213 information schema, MySQL performance schema. So this command displays all databases. As you can see, our project databases BITS1213 has been created successfully. For step 4, let's select the project database. So successfully changed. Now I select our project database. For step 5, so this command displays the tables in the database. In our project, the database has been created successfully. So that's all. The MariaDB server was successfully installed, the database was created, and the service is running correctly on the server. So that's all from me. Thank you.